calling back is I was like looking online and seeing what Acuity is doing. You guys are doing a bunch of cool stuff. And
Thank you.
I was like, man, the way that we met was interesting because I'd heard of the brand. This is like 2018-ish. I'd heard of the brand. I didn't know who you were. I didn't know you were in charge of things. I was putting together a 10th gen Civic Si for Honda when I
Yep.
was with Motor Trend. I was doing
Yep.
something for SEMA. I think you or somebody from your company had reached out to Falcon, wanting to reach out to one of our sales guys to get in touch with
Yep.
me and
Yep.
basically to see if I wanted to try some of the parts out. And I went to the website and I was like, oh, that's pretty interesting stuff. I'll check it out. You guys sent over a
Was
shifter. It was for an SI. You sent over
Yep. No, I remember. I'm just curious. What did I feel like we might have worked together before that on Kevin Boehm's K20 C1 swapped 10th gen SI, or was that
for
after?
that was after. That was actually after. And so what we had done is you sent over like a shifter, you sent over
Yep.
the shifter bushings, a pedal spacer, a few other things,
Yep.
shift knob, things like that.
Knob. Yeah.
And I was telling the sales guy, I was like, look, I've heard of the company, but I've never had any actual parts on my hands. I go, if it comes and it's not up to par, I'm not going to use it.
Throw it out.
So, and I think I told you, I'm going to be brutally honest with you. If it doesn't work, I'm going to tell you I'm not going to use it.
That's
And
what we tell everybody that uses our parts. We're like, if it's trash, throw it out.
right, right, right. And so it showed up, and I pulled it out of the box, and I was like, wow, it's like really, really good quality. You had the
Thank you.
little labels, like the little torque
Yeah.
amounts, how much torque to apply to each of the bolts. I was like, man, this is really nice. So I remember I installed it, everything went in smooth, it worked great, and I was like, all right, cool, like this stuff is legit. And then we kind of became, more acquainted after that, and kind of became
Yeah.
friends. And that was, that was a while ago. It was before COVID. And so
Yeah. That
what's
would
going
have
on now?
probably
Like,
been
where
like,
are you at
what was
now?
that? 2018, 2019.
2018, 2019-ish, yeah, like right before COVID.
Man, so let's see. We had a since then we've released our 8th gen shifter. That was really cool. I wish you could get your hands on one of those. I wish you had a 8th gen.
Don't
Those
say that
that
because
was
I'll go buy one and then it's gonna
You
be a
should
whole
go
thing.
buy one, man,
I have
because
three
I
cars
that
here, no
shifter
room. Yeah.
I'm really proud of that one. We started getting into so like when we made the 10th gen shifter that you tried, we made the main pivot of it from scratch. So like the whole spherical joint and everything was our own design, and we had like a wear compensating feature built into it so it'd last longer. But there was a little bit more friction that I liked in it, and a little bit more compliance. So with the 8th gen shifter, I don't know if you've looked at one, but they're tiny. They're
Yeah.
tiny, tiny.
I had
And
an 8 gen before. Yeah.
yeah, yeah. So it is a real challenge to design a good shifter for the 8th gen. And it kind of forced us down a path that was just necessity of using spherical bearings, like, aerospace bearings that we swaged into the housings instead of using retaining rings. So we actually like deform the housing the bearing goes into, and then we can clearance the bearing and get the friction down. But we went to that, and it was kind of like this eureka moment that we were like, man, we should have been doing this all along. This is great. The performance we got was excellent. It was lighter. It was very, very strong, very little compliance. And we're going to have our 11th gen shifter coming out probably end of May. Um, and so end of this month, if this is, put up by then. But
Yeah.
it's built off all that stuff from the 8th gen. So we've got the chrome steel spherical bearings that are swaged in and clearanced, and we kind of rethought how we designed springs too. So do you remember on the 10th gen shifter how it had really snappy centering, but it
Very,
was
very
pretty
snappy.
aggressive, right?
It was. Yeah. Yeah.
Yeah, so on the 8th gen we tried to tone it down a little bit, but one of the things that we did was on a coil spring, if you add coils, what you can do, and you add coils and you make the wire size bigger, you can get the spring rate to go down while getting the load to go up, and it starts to make like a more linear load as you're moving the shifter from left to right. So if you let's say you have like 5 pounds of centering force at the center, it's not going to go up dramatically when you move it to the left or the right. Whereas if you have a spring with a really high rate, it might go from 5 pounds when centered to 10 at the side. And you really have to fight that. So we got our spring rates a little bit more linear. We also what was it? We were coming out with like optional springs, so like lower load, higher load springs. Because what we the feedback that we got from the 10th gen, most people loved it, but some people would say like, "Oh, my girlfriend drove the car, or my mom drove the car," and
Okay.
they were
Too
fighting
much.
it, and so
Yeah.
I can't let them drive it because they can't shift it so well. And then the other people that we got complaints from on the stiffness of shifting was actually the right hand drive market, and it took me a while to figure out why that was. But eventually I realized it's because they're using their non-dominant hand to shift. So
Yeah.
you're using your left arm versus your right arm, and it's going to respond a little bit differently.
Yeah.
So on this shifter we got coming out for the 11th gen, we really tried to take a lot of feedback, and I hope you'll get an opportunity to use one because I think you'll be really impressed at how far it's come since the 10th gen.
Well, the tension, I'm one of the people that actually liked the way that it felt. I thought like the amount of tension it had was perfect, and it was a huge improvement over stock. So,
Yep.
and that was a daily driver. I loved it. So I actually have also one for my K-swap car as well,
Yeah, you
like
have
you guys
is
did.
that the RSX shifter in there?
Yeah,
Or
yeah, yeah,
yep.
yep.
Yeah, that's probably one of the crowd favorites.
Yeah, that one's really cool. I love that one, the adjustability. It worked really well, but it's sort of become your bread and butter in terms of you guys doing all these different shift options and
Yep.
accessories. What's sort of the amount of time it takes from start to finish when you're doing R&D and D and you're developing something? I mean, I'm sure it
Way too
differs
long.
from car to car, right? But
Yeah, yeah, it does. And like based on how similar it was to something we've done in the past.
yeah,
But
right, right.
with these last few shifters, we've had to do a lot of like I'd call them architectural changes. So like another thing that's really different about this upcoming 11th gen shifter is we're using a totally precision die cast frame instead of sheet metal, and it
Oh,
gives us
okay.
way more design control. We can make it lighter, we can make it stiffer. But the problem is, as we've grown and we've kind of like developed the shifter architecture, we have to invest a lot of time when we're kind of making like a dramatic shift in how we build the shifter. So like this 11th gen shifter, I think I started about 2.5 years ago on.
Oh, wow. Okay. So
Now
it's
yeah, I work on other projects,
yeah.
in parallel, but I mean it's really not uncommon for something to take us about 2 years of development. I may 3D print the shifter like 5 to 10 times over the course of development. We may get machine prototypes made, 2 to 4 times. And every time, you're printing something or you're having something machined that adds some lead time to it. And then I have this test rig behind me. This is our
Which I've
shifter
seen
test
before.
rig.
It's crazy.
Yeah, yeah. So this we use this for testing shifters. We use this for testing cables. We don't have cables yet, but we've actually been working on cables whew, over 3 years. I think almost four now. Just doing like like unimaginable amount of testing. I think we've done something like 15,000 hours of testing on shifter
Holy cow.
cables.
Yeah.
But yeah, so this is the test rig behind me, and we have tests that take 6 months, and there's no way to accelerate it. So sometimes, we're just like, okay, we're going to turn it on, and hopefully it makes it through the test. But if it makes it 5 months through and it doesn't make it to the 6 month that we're running it, then you start over. And that's kind of product development here. We try to compress it as much as we can, but sometimes it takes as long as it takes. But that's just what you do when you want to make it right.
Yeah, I mean, you're talking. We should probably take a step back because you're talking about, the spring rates in your shifters and all the testing and all the stuff that's involved. You're not just kind of throwing stuff out there. You've got a pretty significant engineering background.
Yeah.
Take
Yep.
us back a little bit to like high school into college time. Because
Yeah.
how did you go from making custom guitars to messing with Ferraris and then where you are now?
Yeah, that's a good question, and I can't say it's planned. So
Right.
anybody out there trying to recreate it, I would say just
Don't.
look for good opportunities in your life, but don't try
Right.
to plan the path too much. And I think you know that too. You've done the same thing in your
For sure.
career.
100%.
So
Yeah.
in high school, I was a little bit into cars. I had a really clapped out '86 non-turbo automatic 300ZX. I think I
Oof.
paid, yeah, it was a shit box, man. I think I paid like $1,500 for it. This would have been in like 2004. But I came from a modest family, and getting that car was everything to me. I like there's so many things wrong with it, but you take the T-tops off and you play some music and you're feeling
Yeah.
pretty good.
Yeah.
But back then, in terms of like design and fabrication, I was a lot more interested in guitars. I enjoyed playing guitars, but coming from a family that did a lot of hobbyist woodworking, I was really interested in building them, especially since back then when I was in high school, I couldn't really buy what I wanted for guitars. You want the nice Les Paul or the nice Fender or something. And so I
So
was like,
when
well, if I, yeah,
when
if
you
I,
say
if I,
build when you say building
so
though, are you actually forming like the
yeah,
actual the whole
I would just start with boards.
really? Okay.
Yeah, so it was totally from scratch, making the neck totally from scratch, the
Wow, okay.
fretboard, fretting it, making the whole body. I even wound some pickups. I didn't always use my own pickups, but I wound some pickups. And I made some acoustics as well. So, you're carving all of the support structure inside of it, and you're learning like how to fine tune the guitars and do all the setup and everything. And so that wasn't really like automotive related at all, but that is kind of where I started learning how to design things and how to fabricate. I also got into metal sculpting in high school, so that's kind of where I learned how to like use a welder, do metal forming, and things like that.
Nice.
But then, so I went to college. Um, I kept building guitars while I was in college for a while, but I also joined the Formula SAE team. Which do you know anything about that?
No.
So that is a collegiate series run by Society of Automotive Engineers. If there's any engineers that are still in college listening to this, you should see if you have a FSA team at your school or Baja. That's off road. But that was really where I kind of got to start experiment and learn about cars a little more. In that program, you basically take a 600cc motorcycle engine. You can use smaller if you want, but it's capped at like 610 cc's, something like that. And you're building an open wheel race car from scratch.
Wow.
So you're designing the chassis, you're designing the suspension, putting the engine in, getting the drivetrain working. And, like a lot of times the cars don't turn out that great because it's a bunch of college kids building them. But that was definitely like pivotal in me moving into the automotive industry and learning about it a bit more.
Did
So
you
sometime
did you move into that because of the fact that you like to work with your hands, you wanted to develop something, or was it the car itself and kind of like, oh, I want to get
No,
involved in
so
this?
that's the funny thing. Being in the automotive industry has never been totally about the cars for me, and that's kind of weird. Like I'm a car guy in some sense. I love driving, a fun car. I like something that is makes for a spirited commute. I don't mind going to the track once in a while, but I really like the challenge of optimizing like one part or one system
Right.
and focusing on that. So when I got into FSAE, one of my interests was composites. I just wanted to learn more about composites. So I became the person who did all the carbon fiber and carbon
Wow.
Kevlar stuff,
That's
making
cool.
intake systems, the body work, the diffuser, and stuff like that. And I did that for like 3 or 4 years. At some point in that time span, I stopped building guitars. The house I was living in got robbed. They kicked the front door off the hinges.
Oh,
Yeah, I came home from college, and my front door was on the ground in my living room, and all my guitars were gone. I lived in a little bit of a rough part of town, but all the guitars were gone, and I just kind of at that point I was like, man, I think I'm going to sell this house and just focus on finishing school. So that was kind of actually when I stopped building guitars. But I'd fallen out of love with it because I started building guitars for other people for money, and I didn't really like their taste. So it kind of
oh, okay,
spoiled it
okay.
for me,
You
and,
turned
and
into
like
American shoppers. You're building
yeah, it
stuff you don't
was
want to
it
build.
was when I was doing it for myself, it felt very pure, and I was
Sure.
like pursuing something that felt like noble. I was trying to make really high quality stuff. But then when people started paying, uh, the stuff they had me make, I felt like a lot of times was kind of tasteless. I felt like it
Right.
wasn't practical, and it just kind of took what I loved out of it. But
Got
then I
it.
kind of
Got it.
found that again in the automotive industry.
Sure.
Because I really was drawn to the automotive industry because the thing that bugged me most about building guitars was that it was really, really subjective. You know, everybody's like looking for the best tone. And I'm going to offend some people saying that. But, you know, it became more obvious to me that, you know, if you just had a decent guitar and you were a good guitarist, it you didn't really need much more. You know, you didn't need this magical perfect guitar. And getting into the automotive industry gave me an opportunity to kind of take on projects where like the quality of the work that I put in would be better reflected in the end result. And
Gotcha.
that's one thing that I love about making shifters and shifting components. If it's trash, you're gonna know it's trash.
Right.
And so
Right.
there's a lot of pressure on us to deliver something that's excellent. And I actually thrive on that. You know, I love that. I don't like being in a industry where you can kind of like hide shoddy workmanship. And while you know there's some of that in the automotive industry, I think the purists are pretty good at spotting
Yeah,
the good stuff and sorting it out from kind of the
for sure.
chaff.
For sure.
But so you know, I go through college. I'm in FSAE. At the time, I'm working for another small business in the industry, and it got to the point where it just felt like that wasn't the right place for me to work anymore. But it was automotive related, and so that you know that really appealed to me. I wound up. I just needed another job. This was shortly after leaving college, and I wound up at a conveyor belt company. And I was in their R&D department. There were maybe like 200 engineers, and I was in this group of like 10 engineers. And all the other engineers in the company, they would design conveyor belts for different applications. Like the company mostly did food service stuff. So like you know Tyson Chicken, places like
Right.
that were buying conveyor belts off of them. But I worked in this little group that made test equipment. And our only purpose was to build equipment for testing new conveyor belts that the other engineering teams were designing. And that actually, oddly enough, is where I figured out, you know, how to make equipment like this, or that's where I
Yeah.
learned how to make equipment like this. So we were testing stuff that was like stretching conveyor belts or just running them continuously, applying varying loads, learning about building like frames for this kind of test equipment, learning about the control systems, all the sensors and stuff like that. And I did that for 6 months, and it was pretty fun. And it eventually got to the point where it started to feel kind of repetitive, and I started to kind of yearn for the automotive industry. But I didn't have any plan to get out. But then I had a friend of mine call me up, and he was like, "Hey, are you still looking for a job? There's this company that makes heat exchangers for you know racing applications, and they're hiring, and I think you'd be a good fit for it." And I felt a little guilty. You know, you take a job and you're only there for 6 months, and you don't want to leave because it looks bad on your resume, and
Right.
it's not kind to your coworkers there who I'd built a good relationship with. But you know, the more I looked into this company, I saw they were working with like Ferrari, Porsche, Audi, just all sorts of really interesting companies. And I was like, man, I have to, you know, go to this interview. I have to at least try. So I go to the interview, and that goes pretty well. And I was like, man, I'm going to feel so guilty if I have to quit this company making conveyor belts after 6 months. So I was like, let me just ask for like a salary that I don't think I'll get. You know, something
That's a
reasonable,
good way.
but something that was a stretch because I was like, they'll just say no. And I asked, and like maybe a month went by, and I was like, they don't want me. There's no way. And they call me up, and they're like, hey, when can you start? And I was like, oh shit. So I left the conveyor belt company and wound up working at this other company. They're called Meso Technologies. They're still around, but now they're in aerospace and defense and stuff. But I wound up working there about 4 or 5 years. The first project, you want to talk about stress. The first project, and I was probably, I don't know, maybe 25, 26 at the time, was a test prototype for Williams for one of their F1 cars.
Oh, okay.
Yeah, no pressure, right?
Yeah, nice. Yeah.
Um, So that went pretty well. Williams wound up the radiators were really expensive. I think they cost normally $50,000 to $100,000 a piece,
Uh-huh.
because they're made with hypodermic needle tubing. So
Jesus.
like the same tubing that you're getting like your vaccinations with and stuff. And I wound up. I think the second project I got put on was an intercooler for Ferrari F1. That's I don't know. Have you ever seen the engine in the Ferrari cars
Yeah.
and where the intercooler is located? They actually
Yeah.
stuff the intercooler into the V on
Right.
the engine, and the pressures and temperatures are absolutely absurd in F1. I don't remember everything, but I remember I think the air pressure was something. It was like at least 7 or 8 bar, which you're talking like 100 psi
Yeah.
of charge air pressure. And so that was a really good engineering challenge. That stuff was a lot of fun. Worked with them. Let's see. We worked on the Porsche LMP car. I've got some notes here. That was the 919. Uh, and so I don't know if you saw, but after the 919 program, that car went and set records at a ton of tracks. Um,
Were you doing the same thing? Like you were working in the cooling portion of that?
It was always cooling. It was always cooling. So the
Gotcha.
question was
Gotcha.
always which kind of heat exchangers we were working on. And on F1 and LMP cars, there are a lot.
Yeah.
So, you have like the KERS system, you have gearbox oil, there may be multiple gearboxes, you have engine oil, you have the coolant from the engine. Sometimes you have air to air charge air, sometimes you have air to water charge air coolers. In rare occasions, you might have both. There was one project we worked on. I can't say for whom, but we actually had a all plastic radiator or all plastic air to air intercooler. So it used like high tech plastics. But then after the intercooler, it would route through a refrigerant system. So it basically had like a custom like AC system just for cooling charge air.
Wow.
And on that project, we got the charge air on that race car down. I think it was like maybe 5 or 10 degrees below ambient.
Wow.
So yeah, it was
So
wild stuff. It was wild, wild stuff. I got to the traveling was probably one of the coolest things from that. I got to see Ferrari's F1 facility in Maranello. We went to Weissach. You've heard that before.
yeah, of
Went to
course.
Weissach to meet with Porsche. We went to I got to look up where this was. Audi's facility, which technically is joust racing. They're in a place called Wald Mickelbach, I think.
You made that up, but go ahead.
Smell, yeah, it smells like a cow farm. So if you ever go to joust racing, just be prepared. It's going to smell like cows because they're out in the middle of nowhere.
Yeah.
But got to go to McLaren, the mothership. That was crazy. That's like being in a Men in Black movie, going to McLaren.
Right, right, right.
Uh,
Right.
but yeah, it's just crazy, crazy experiences there. I've got a list here because there were more than I remembered. Um, do you remember the Nissan GTR that was at Le Mans in 2015? It was a really
Yes. Mhm.
funny looking car.
Yep.
I designed most of the heat exchangers on that car.
Wow. Okay.
That was really cool. That car did not do well. It was super experimental, but it was a wild experience being involved on that. And then another one I got here is do you remember the Pratt Miller ATSV race cars?
Don't think so.
It was exactly what you expect. It was a race prep version of the ATSV. It came from the factory like all caged and everything. And we did these wild intercoolers for that car that were it looked like a filter out of like a shop vac, like a cylinder. But it was this carbon cylinder, and so the air goes in one end and then comes out the other end, and it flows just like a filter in a shop vac, going in the middle and then
Wow.
out the sides. And so that was what I did before Acuity, and between working at the conveyor belt company, learning to make test equipment like this, and then working at a company, directly working with F1 and LMP engineers, it just gave me such a wide range of experience and experience in design, experience in testing. It's been really really cool to apply that to consumer products, things that people can actually buy.
when you were kind of jumping between the different manufacturers, were you almost like a freelancer, or how did
No,
that work?
no. So I worked for this company, Meso Technologies, that made the
Yep.
heat exchangers, and all of these companies would come to Meso and they'd want a heat exchanger made, and then I was basically like a project manager,
I okay, I get
and
it.
a
I see.
design engineer. So
Gotcha.
my boss, who his name was Tony, and he was insanely smart. That was another thing. Working at that company, I just got to be around so many people that were smarter than me. Um, a bunch of people with PhDs and masters in engineering. But those projects would come down to me, and then I would spend time with the company the project was for, whether it was Ferrari or Porsche or whoever, and start to try and understand their goals a little bit better. And then we'd go through kind of this iterative cycle where we're running all their data from the car, like what are inlet temperatures, charge air inlet temperatures, oil inlet temperatures, and stuff like that. We'd run it through our software and we'd say like, hey, can you guys fit a core that's like this size? And then we'd say like, for a core that this size, we're going to need end tanks that are about this big. And you kind of start going through that process back and forth, telling them what you can get them if they get like say like, okay, if you give me the space the size of a shoebox, I can get your charge air from this temperature down to this temperature. And then
Gotcha.
they'd say like,
Gotcha.
oh no, we actually need it a little bit cooler. And then you go back and you're like, well, okay, I need this much more space. And you kind of iterate. They're dropping like placeholders into their solid models, giving you feedback. It was pretty rare that we ever got solid models from any of the teams because in F1 and LMP they're playing the cards really close to the chest.
Of course, yeah.
So
Everything's under
like
wraps.
if an F1 team is going to send you CAD, they're going to send you like the absolute smallest amount of it as possible. So like whatever you
Right.
get, you're going to get this like little surface here and another one there and there, and they're going to say don't touch that stuff. But you have no idea what you're looking at because they're so small. You're like, I know this is somewhere in a side pod, but I have no idea where this is because the shapes are
Right.
just obscure. But yeah, so you do that back and forth, and sometimes there'd be testing involved. So like sometimes we'd have to send out heat exchangers to wind tunnels, but it's not the wind tunnels that you think of. So these would be closed wind tunnels where you're simulating the flow through the duct on a car, not the airflow around the car.
Gotcha.
So the heat exchanger testing is normally done separately from what you see like in a wind tunnel. They might have the heat exchangers in the car, but they're not always like running the car or actually like generating the thermals from it. And like it kind of depends how precise they want to be. Because when you're dumping all this heat into the air in the side pods, it does have a pretty dramatic effect, or it can, on what's coming out the back. Because you add heat to air, suddenly either the pressure or the volume is going to go up, right? So you're getting like higher air velocities coming out the back of the side pod because you're dumping all this heat into it. And they kind of have to decide if they care about that. But we'd send the testing house we used, I think, was in London. I don't remember the name of them, but we'd send them a radiator and we'd say, hey, these are like the inlet temperatures for the air and the oil and the water. And then they had like heaters and stuff like that. They didn't actually have to run an engine. And they'd basically simulate this radiator running in the car without having it attached to anything else from the car. And they could get all the thermal data out of it and tell us if we were like consistent with our expectations or not. But we were pretty good at getting it pretty spot on. And I don't know how much you know about radiators, but in the automotive industry, so like a tube and fin radiator on a normal car, you're not gonna get like all of the thermal transfer you can out of it. You're gonna get maybe like 60 or 70% of it. And there's a lot of heat that goes through the radiator and goes back into the engine, right? Because your radiator outlet temperatures are never ambient.
Right.
But in these pro racing products, a lot of times you have to get like 99% of the heat out of it. So we were like thermally, what we were doing was like really insane. We were getting every bit of heat out of one fluid and into another. So it was really challenging, but it was really really rewarding.
So how then did you? come up with the whole idea for Acuity? Because it seems like you were doing something you were fascinated with, you were interested in it, you're good at it.
Yeah,
Why
yeah.
switch?
So the first thing is why would I get out of it? Because to be honest, if that job had continued, I probably would have never started Acuity.
Okay. Okay.
I loved doing that. Like that was dream job, dream job. Acuity is too, but you're not gonna like give up one dream job for a possible future
Sure.
dream job.
Yeah.
And so I was kind of on the trajectory to take over the motorsports division at that company. The whole plan was there was another engineer that was a little bit older than me. He was going to take on all of the non-racing stuff, so that was like aerospace and defense, and I was going to take over racing. But then, do you remember Dieselgate?
Oh yeah.
So when
Oh yeah.
Dieselgate happened, that kind of ruined that dream job for me. So it wasn't
Oh,
because we lied about emissions testing.
right.
It was because all of the companies that were worried about getting hit by Dieselgate, and Volkswagen owns like tons of brands throughout Europe, so like a lot
Right.
of the teams we were working with were affected. When that happened, they were terrified that they weren't going to be profitable, so they reduced their racing budgets dramatically. And because we were selling radiators and intercoolers that were like $50,000 $100,000 a piece, we looked real juicy for the chopping block to cut their
Yeah.
budget.
Right.
So
Right.
all these teams were basically like, we're just going to take the hit on cooling effectiveness. We'll try to find our performance in other areas that are cheaper, and we're going to drop all these cooling products. So when that happened, I got moved into aerospace and defense, and I was starting to work on projects related to like tanks, weapons, airborne weapon systems, things like that. And that's really cool, but it felt a little morally gray to me.
Yeah.
Like
Understood.
I understand that weapon systems are kind of a necessary evil in the world,
Sure.
but
Yep.
when you're like designing it, like it's like I say, when I design something, I want to do the best I can. But there felt like a conflict between doing the best I can and not knowing if this stuff was going to be used for something that it really needed to be used for, or if it was just going to make some white old dude in America rich. Like I didn't want to be attached to what might happen with the stuff I was designing. So I felt kind of like, I don't want to say a moral obligation, but I felt a strong push to get back into automotive. I also missed automotive. I missed it a lot. So basically, the thing I didn't know Acuity was going to be a shifting company. I had some prior experience designing linkages and stuff that was very similar, but originally we were trying to be a sensor company. So you used our TPS? Do you use that on your SWAT?
I have it on. I have it on
Yeah.
my car. Yeah. Yeah.
So I was a little naive at the time. I knew that the RSX TPSs were hard to come by. I knew a little bit about designing circuit boards because I'd done a. You remember Kickstarter where you could like come up with an
Oh
idea and
yeah.
get other
Yeah.
people to
Yeah.
fund it. I had
You were on
kickstart.
there.
Yeah, I had kickstarted this project that was like this ferrofluid sculpture that danced to music. It was just something I did for fun. But I had learned about circuit board design, and I was like, man, I could use that knowledge to make a Hall effect TPS sensor for the RSX because I knew that was something that was needed. And kind of the idea at the time was we were going to look for these, or we called them orphan sensor applications, where like maybe the company doesn't make the sensor anymore, or it's part of an assembly and you can't get it easily. And so we made the RSX TPS, and it did well, but it didn't do quite as well in terms of volume as I thought it might. I don't know if that means that like more people wanted to get cheaper TPSs or if the market just wasn't that big. I could have totally underestimated that because I was very kind of fresh to figuring out markets like addressable markets and stuff like that at the time.
Right.
But so we designed the TPS, we launched it, and it quickly became apparent that like while it was selling well, it wasn't selling nearly well enough to support like a small business, and we just couldn't identify enough other sensors to basically make that a full company.
Right.
So I was like, I don't really, I don't totally love all of the shifting products that were on the market. It was something that I understood. And I was like, let me see if I can come up with something that I feel like adds value to the Honda market in the shifting category.
Right.
It was a fun change of pace. I was previously working on heat exchangers; they don't move. So having to get into shifters made me, tackle new problems that I hadn't tackled and things like that. But I drew a lot on what I did in heat exchangers because like a lot of the work that I did in heat exchangers was finite element analysis, doing either analysis to figure out like stress and stuff from mechanical loads, like, vibrations or acceleration, stuff like that,
Mm.
or even finding stress from like thermal loads. So, like a radiator, you don't think about this a lot of times, but when a radiator heats up, it gets this thermal gradient across it. And thermal gradients can really wreak havoc for stress on parts. So, I had to do a lot of FEA related to thermal stuff too. But so I had that strong background in FEA, in testing, and I just wanted to see what we could add to the shifting market, And I was like, well, we'll design some parts, and we'll do our best with them. And if people think that they're good, then it'll do well. And the first shifter we came out was the ninth gen shifter. Nobody was making a shifter for the ninth gen application at the time. So that seemed like an obvious market, even though these days it's not a particularly popular platform.
Right.
But we started there, and the reception was excellent. And so then we just started kind of filling in the blanks, making other shifters for popular Honda applications, trying to make them a little bit better every time, try to experiment with new things like the swaged chrome steel bearings or, die casting to get our weight down and our stiffness up. And it just kind of snowballed over time. But there was this really cool tie-in from what I did in cooling systems into what we do at Acuity. So we sell a few sets of radiator hoses. I don't think you had any on your Civic because you had an
No,
SI for the
yeah,
10th
yeah.
gen.
This is the
Yeah,
reverse
and
flow thing, right?
yeah,
Yep.
exactly. So on the 10th SI, the water flows left to right, and that's significant. Basically, one of the things I got good at while I was working at Mezzo, working on cooling systems, was looking at all the inlet temperatures on fluids and looking at outlet temperatures, and figuring out basically how to stack heat exchangers. In cars, a heat exchanger stack, like in road cars, looks like intercooler, and then you've got your evaporator or condenser rather,
Yep.
and then you've got your radiator, and that's very intentional, that sequence, because what the different heat exchangers have to do and what the expectations are, for outlet temperatures. But I got really good at just looking at those stacks and getting kind of an idea of if it's thermally optimal or not. And now you can always do better doing analysis, but you kind of start with just rules of thumb, and then you're like, okay, let me pursue that and go into analysis. And so when we started working with FK8s, I started looking at data for inlet and outlet temperatures on water and charge air. And we actually did a little bit of testing where we put some sensors to measure the air temperatures coming out of the heat exchangers. And we figured out that it seemed like there was a pretty good odds that if you flowed the FK8 radiator bottom up, which is very untraditional, that we would get better cooling performance. So we actually had a contact at HPD, which is now HRC,
Right.
Honda's
Hmm.
racing branch, and we reached out to him and told him our suspicion, and we were like, "Look, we don't have the test equipment to like validate this to the level that we'd like to. Could you guys maybe help us?" And they came back to us and they were like, we're having a little bit of struggle with cooling on our race car FK8s that they were selling at the time. The TC and then the TCR cars.
TCR, yep. Hmm.
Yeah, TCA was the SI, so the Type R was the TC, and then their car that I think is built in Italy was the TCR. So they got us on the TC project, which is basically like a stock gutted caged FK8, And I don't remember the exact amount that we reduced the water temps on it, but I think it was something like 5 degrees Fahrenheit at full load just by flowing the radiator backwards without even swapping a radiator. So they started using the radiator hoses on those factory TC cars. And now I think we've got our FL5 hoses on their Integra Type S race cars that they sell from the factory.
Very cool.
So yeah, so that was a really cool way for me to kind of like leverage what I'd done in the past into Acuity, and it was really cool to benefit HRC because it's kind of hard to approach company organizations like that and actually
Well,
deliver
yeah.
some value.
So yeah, something that big especially. But when it comes to testing, obviously you guys do a lot of testing there in house, but then you also do a lot of real world testing with the grid life cars, right?
Yeah, so we don't look at the race cars so much for testing. It is a part of the testing,
Yeah.
but I've rarely learned something on a race car that I didn't previously learn on the test rig. The things that the race cars are good for are looking for vibration related issues, and then thermal issues. Because on our test equipment, we're not simulating like cockpit temperatures or things like that. We had one instance where we went the other way, and that was really scary, but it was really fruitful. So on this 11th gen Civic shifter, I designed the first version of it. Let's see, the summer of 2023, because that was the year that we had a SEMA booth, and then we went to Thunderhill with THRW, which is one of the employee racing teams at Honda,
Right.
operated off
Right.
the West Coast. And so I had just designed this shifter. Like it hadn't gone on the test rig very much. We were doing a little testing, but not nearly as much as I'd want if it was going on two race cars that are operated by Honda. But I did enough testing that I was like, okay, I think we're gonna make it through a 25-hour race. I don't expect that we're like putting them at risk or anything because we wouldn't want to do that. Put something in the car that might make them lose a 25-hour race. That'd be really really bad.
Right. Right.
But at the same time, I don't really like to distribute prototypes until I'm like 1,000% certain of what I've got. So I kind of bet my own rules a little bit, and we put them in those race cars. They had really wanted the shifters, and then we also did a proprietary intake for those cars too. But those shifters ran in those cars for the 25 hours of Thunderhill back in 2023, no problem. Their FL5s won first and second in class, and we wound up putting all the testing into it still afterwards before we launched because it's been, I mean, that was almost a year and a half ago, or it was a year and a half ago. But yeah, that was one time that we kind of did it the other way around, where we put it more in the race car before we put it on the test rig, and I'm very pleased to report that it all went smoothly,
Yeah.
and it
Yeah.
wasn't bad finishing first and second either.
Yeah, and I mean, if you look at coverage from Grid Life, or if you go to it, there's your guys' livery is on like the majority of every
We
Honda it seems like has a sticker somewhere
Yeah,
on
yeah.
there.
So we try and support the guys at Grid Life as much as we possibly can.
We actually sponsor a lot of the same vehicles
You guys
too.
do too. Yeah,
Yeah.
you
Yep.
sponsor you sponsor
Yep.
Jim. He's got the
Hmm.
fit. You guys sponsored. He's
Mario.
not racing anymore. You're on Mario's car as well. Yeah.
Hmm.
So you're on Mario, but you were on Evan Weeder's car. That was the
Yep.
EG that we had sponsored previously as well.
Yeah. Yeah.
They
Yeah. You
yeah, and
see.
they've been very very pleased. They've been very very pleased. You guys have done right by them. I don't know all the details, but I know they're happy.
Yeah, and those guys are always out there. They're always putting in the work. So it's
Yeah.
good to have that stuff out there. You can actually see the product that you produce, being put to work.
Yep.
You know.
Yep, yep,
Yeah.
yep. Yeah, those guys, man, I can't tell you how many times I've seen them do overnight engine or transmission
Yeah.
changes. They're
Yeah.
like,
Yeah.
they're used to it. When it
It's
happens, they're
part of
like,
it.
that's
Yeah.
fine. Yeah, it's part of
Yeah.
it, but they're tough, man.
Yeah. So now at this point, it's been a few years. Acuity's definitely established. You kind of like uh, kind of set the bar in terms of the short shifters and some
Thank
of
you.
the other parts you make as well. What's next? Like, what are you guys working on now moving
That's a
forward?
good question. So the thing we're going to be releasing soonest is going to be this 11th gen shifter, and I know everybody's going to be really pleased about it because our customer service people tell me that they can't stop getting emails about it. It's nonstop. So we have the 11th gen shifter coming out at the end of the month. That's going to be really cool because there's a lot of firsts for us on that. We've got a bunch of accessories coming out for it. We've never done that before. So we've got different things like different rate springs. We've got titanium upper rods, which is like normally it's a stainless steel rod that you mount
Right.
your shift knob to. We've got them in all different titanium finishes. We've actually, I know you're gonna like this. We started dabbling with Cerakote. I know you're a Cerakote fan.
I am huge fan. I love it.
Yeah.
I love it.
So the part of the shifter that the upper rod goes into, where you adjust the height, we call
Yeah.
that the adjustment body, and we've got all these wild finishes of Cerakote on those, so that you can do like a little bit of customization. So those will be cool. That's going to be coming out. The Cerakoted stuff will probably be coming out like end of I guess June. But that's a little less certain than when the shifters are coming out at the end of May. But we've got that. Have you seen our shift knob charms?
Yes. Yes. Yep.
So that was a weird product that we came up with. That actually kind of came out of Call of Duty. Uh, I was just playing one day and I was like, you put charms on the gun,
Right.
and I was like, why is nobody putting these on shift knobs? So we wound up coming out with this line of rings so that you can put them under your knob and support the charm from that. But we've got season 2 of the shift knob charms coming out in about, I'd say, a month and a half. So people, at least people that are familiar with the charms, are going to be pretty excited about those because those were a huge hit when we came out with the first season. Then probably the biggest thing that we have in the works is a line of shifter cables. Those we've been working on about 3 or 4 years. There's all sorts of weird things that problems you have to solve and things you have to test with shifter cables. And those tests, normally we're doing about 10 million shifts in our like long life tests. We have some tests that use fewer shifts and higher loads, but each of the cables that we're testing has to go through 10 million shifts basically, and you can only accelerate the test so much before you get false results. So those tests normally take about six
Oh,
months. But
wow.
anyway, so those cables, I think they might come out by the end of the year, if not early next year, because we're wrapping up the last few tests and everything's been going really swimmingly. We've got some that have been on road cars for 3 years now. But we just kind of like fine tune this and that. There's different things like they've got bellows, and so you have to do a test on the bellows and make sure that those can go through 10 million cycles, and then rod ends that we designed, and then the cable cores and stuff like that. But those should be coming out at probably around the end of the year, and those are going to be wild, man, because that's going to be almost every single Honda application from 2000 onward. So yeah, it's going to be cables for everybody. Whenever we release something, I mean, you always probably get this at Koenig. You release one product, and then everybody whose car it doesn't fit for says, "Where's the love for
Right.
my car?"
Right. Right.
Right?
Right. Right.
Why doesn't it
Yeah.
fit a
Yeah.
Focus RS? And
Right.
so
Right.
we laugh about it, but I'd love to be able to accommodate everybody as much as possible. We only have about 6 employees. We're a lot smaller than people expect. But this will be one of those cool product drops where we've got something for like almost everybody in the Honda community. We even have obscure stuff like cables for HRVs.
Really.
You wouldn't believe how hard it was to find a manual HRV for that install guide. Uh, Powen lives in Boston. I think he had to go out to California to make that guide. He found like one manual HRV.
Wow. So for you guys, I mean, a lot of the stuff you're doing uh previously and now it's always based on the newer Honda stuff. The cables are going to stretch back a little bit, right, to the early 2000s, but
Yeah,
do
yeah,
you
yeah.
have
So
do you have other
sorry.
thoughts of doing stuff like maybe B series stuff or anything outside of what you're doing now? Like
So
is
yeah,
is there
we
is there a
we
lane?
yeah, so we do have actually quite a few projects lined up for older stuff. It seems like we only work on the new stuff, but the real truth is when a new car comes out that we're interested in, we do prioritize that.
Sure.
But when those projects are complete, that's when we work on backdated stuff.
Gotcha. Okay.
So we do slot in backdated stuff into our schedule. It's just newer projects always take the priority, because some like with a new vehicle, it's easier to kind of predict what your unit sales are going to be, whereas with older products, it's a little bit more of a risk. So like I'll give you an idea of some of the stuff that we're going to be working on after this 11 gen shifter. We've got stuff lined up for all generations of the Honda Fit and the Honda CRZ. What is it? GE8, GD3, GK5 fits, and then the CRZs. So those will all get shifters. And then what's the other popular shifter for K swaps? I think the Accord shifters.
Oh yeah.
The
Yeah.
ones that they look a little funky compared to
Right.
like the RSX shifter. But those are super popular just because those engines and transmissions are so widely available. So we're gonna be I don't remember the exact years, but we're covering I think two generations of Accords, TSXs, TLXs, and then like the Euro R Accord. So we're gonna have a bunch of
Gotcha.
Accord support coming out too. I don't have dates
Nice.
on all that stuff for the Fits and the Accords, but hopefully it will at least give some of our customers a little bit of peace of mind to know that like it's real. We're working on
Right.
it. It's not made
Right.
up. A lot of
Right.
times people say like they're not working on it. That's a lie.
Right.
We are making fit shifters and we are making Accord shifters. I promise.
As far as when you are developing stuff for newer vehicles, how important is being first to market? Is that in your head at all? Like we got to be first, or is it like
That
let's just get it done, let's get
I
it
will
perfect
I
before?
will never ever value being first to market over
Okay,
being the best that we can. When we released the 10th gen shifter, we were first to market, and man, being first to market is awesome. It's super awesome. You sell a ton of product, but that was just coincidence.
gotcha.
With the 11th gen shifter, we're going to be the last to market, and
Hmm,
it doesn't matter one bit. It just gave me an opportunity to benchmark against everybody else's and make sure that we were just meeting a much higher standard.
right.
So first to market is awesome, but last to market has a bunch of perks too. Like getting a better idea of what you're up against and things like that. And so in this case, I actually have a lot of peace knowing that we're last to market because I've got a lot of certainty about what we're delivering. Um, I'm really excited for people to try the shifter. I'm really, really excited. Put a
That's
lot
awesome.
of time
That's awesome.
into it.
Yeah, we're looking forward to it. Well, man, Russ, I mean that you have a crazy, crazy history starting from custom guitars and getting to where you are now. So it was great to talk to you and get an idea of how you
Thank
got
you.
there. Even though it wasn't planned, that's kind of the best way, right? Like you
It's
kind of
been a
just
fun
find your
ride,
way.
man. It's been a
Yeah,
fun
yeah,
ride. I'm looking forward to seeing what's next.
yeah. Awesome, man. Well, thanks for joining us today. We really appreciate it, and we'll see you at Grid Life.
All right, man. See you there.
All right.